Hi everyone. So before we run into the slides, let's do a quick poll. Now, the question is quite simple. No? If you think to your past projects, think if the majority of them, did they end on time regarding schedule or original goals? Or did they run a bit late, could be some days, weeks, or even months? So please raise your hands if they ended on time most of the times. Okay, doesn't sound good. Now, please raise your hands if most of your projects ended late. Oh no. Do it again, so please keep it up, and take a picture. This is just a scientific survey. Okay, too bad. So, is it a problem of Pythonistas? Just of people attending conference? Not really. So in 1975, Fred Brooks said that most of projects failed mainly because of lack of calendar time. It was 50 years ago. 1992, 2/3 of projects significantly overrun their cost estimates. 2001, the average project exceeds its schedule by 100%. 2022, yeah, more or less, we have the same issue. So, but why is it that for 50 years, seems that software projects are always late, but still we didn't find a solution for it? So in this talk, we'll try to understand why it happens, and we have two parts. In the first one, we'll see what are the main reasons that this happens, and in the second one, I try to give some tips that try to reduce the risk, but don't have too many expectations. You will still have some delay. So before starting, we will have a simple example that will help, a simple use case that will help our journey. Imagine a small company with some developers that need to build a conference website like this prototype here. And they are given by their marketing colleagues, these ones here, with nice tissues. They give them a list of features, like 10 of them, and they say, okay, how long does it take to build this website? So let's start from our psychological way of thinking to the problem. How do we think when we make a plan? And is it something wrong? So let's go back to our case. So these developers meet together. They are given a list of features, and they try to brainstorm and think, how long will it take to have these features closed? So each of them try to make a guess. So someone says like 5 months, someone says maybe 10 months. So they have their estimates, but before making it official, they talk with Kate, and she's a project manager which is in the company from a while, and she tells them, hey guys, consider that usually in the past we had similar projects with similar resources and similar complexity, and they usually take 16 months. So please keep it in mind. So the developers look back at their estimate and they say, we will make 3 releases for the first one. Yeah, 3 months is reasonable. Then we'll take 3 months again for the second release, and then 2 months. I mean, look at what we know. Basically, it sounds reasonable. So they confirm their original plan. Then what happens? Of course, they will be late. At the end of the project, they build the website, but it took 15 months. Anything occur, no? They originally planned to have a payment gateway for paying the tickets, but then the terms and conditions changed, so they had to switch to another one, and this took time. Then one of the devs left the company. This also was an issue. Or they had some front-end compatibility issues with the agenda or the schedule of the conference, so they had to change the core framework for the front end. So this took time. I mean, there were some surprises and that they didn't expect and made the project go late. Then, how can we explain this? So there is this guy called Daniel Kahneman. He's a psychologist and also a Nobel Prize in economical sciences, and he calls this planning fallacy. He says that when we make a plan, this is a developer making a plan, there are some information that he can see that is in front of him. For example, the features, how he imagines he will develop the things. But there are some information that are the so-called unknown unknowns. There are some things that we don't know what they are, and we don't know that they will occur. And they are all very unlikely. I mean, this, a dev leaving a company is not likely. A new fail in the front-end company is not likely. But there are so many that still the likelihood of anything happening and the project going late is quite likely. And then he called this bias, what you see is all there is. Then when we make a plan only on what is in front of us, and we don't conceive what can occur, but still can make the project fail. So he defined planning fallacy, say that when we make a plan, we tend to make plans that are unrealistically too close to the best case, and we could improve them if we compare to statistics with similar cases, like Kate said, but we are lazy and we don't do it usually. Yeah, so this is how we think. And then do we have also some statistical bias? So there is this famous survey from the 80s, I think, that say that 93% of US drivers consider themselves and their driving skills to be better than the 50% of US drivers. This is just impossible, no? This means that we are usually, as human beings, a bit overconfident in our skills. Then why do we do this? It's because if, let's go back to a project example. If our project finished earlier, then we were great, it's our success. If the project finished late, usually our brain try to explain it as an external failures. No, I mean, we couldn't forecast that a developer leaves, or we couldn't forecast some compatibility issues. So, it's not our fault. It's just an external reason. So, because we tend to think like this is actually a quote from Taleb. Usually, we don't include external features in our plans. So when we make a plan, there is some uncertainty, let's say plus minus 1 weeks, and usually we consider this to be symmetric. So the project could end 5 days before or 5 days after, for example. But is it really correct? Usually it's recommended actually to model the uncertainty of a completion of a task or a project more like this kind of beta distribution for software development. And why is it? Because the left part, so if likely a task completes in 5 days, still it can end a little bit earlier or quite later. There is a long tail. This left here is so pulled to the right is called the Parkinson's law. That means that if you give a developer 5 days to complete a task, if he finish earlier, like in 3 days, his work will expand like gas, and he will try to, do some refactoring, cleaning of the code, try new tools. Usually, a developer try to fine-tune it, and unlikely he finishes earlier. So that's why it's quite unlikely that you have a left tail. But because of the known unknowns, it's quite likely that things go wrong, and you don't expect them. So that's why you have a beta distribution. I mean, it can be a beta or something similar. So this is, when we make a plan, usually we assume some symmetry that is not true. And when you have many tasks that still have a likelihood, like a likely estimate of 20 days, 15 days, our project likely ends in 60 days, but the uncertainty is not symmetric. So if we sum these distributions, then we have something. The project still can likely end in 60 days, but the uncertainty is between 55 and 80. Well. Clear so far? So this was just an example, but is it a rule? So this is an old reference from Bowen from the 80s, which he defined what will be called the cone of uncertainty. No? So when we conceive and design a software project, there is some uncertainty of how long it will take, how much it will cost. And then at the beginning of the project, when you are in the feasibility phase, the uncertainty is quite large. But even when you are at requirement specification phase, then the uncertainty is like, cost can go up to 1.5 times or can decrease only down to 0.67 times. I mean, we have the literature, we have the reference, so that's it. No? I mean, when we make a plan, then we can just multiply our plan by this estimate, and then we go to our business managers, and they say, I know, please, it's fine, but I need a date. You know, usually the people tend to have, they are not comfortable with dealing with uncertainty. So also companies tend to force to give a date, and that's where the issue comes, no? Because not having a clear date gives a feeling and perception of not having things under control. And that's why things can go wrong. But why do people or business or managers need a date? Well, there is this famous quote by Jan Etzius, which is the chief economist in Goldman Sachs, which he was asked, why do not people give confidence intervals? Because they are embarrassed, so they are ashamed of it. So that's quite an issue, no? Because then we say it's likely 60 days, but then we don't have a symmetry. Last cause is about staffing. This is also a famous quote. Let's start with an example. No? Imagine that a lady is bearing a child in 9 months, and then someone comes to you and asks you, what if I give you a second lady? Can she take 4.5 months? No, I don't think so. But the same holds for software projects. No? I mean, there can be the risk of making the error at the beginning. Say, okay, this project is like 100 days of main development. Let's hire 10 developers and we will finish in 10 days. Now, this does not hold. And there is this famous quote from Fred Brooks from the 70s that adding more men lengthens the project, does not shorten the schedule. You got it. Then I will give you 6 small tips on this. We'll try to go quite quickly. They will not solve the thing, but maybe will let you think on how we can improve. The first one is embrace uncertainty. So when we have a plan like this, no, we have these 3 releases, we are starting 1st of January. Let's try to avoid giving sharp dates, at least at the beginning. Because at the beginning of the project, we have seen the cone of uncertainty. You really are, you're playing an hazard if you give a date. So just try at the beginning to say quite a wide range. We will end sometime between July and September, try to have really large intervals. Then when you start, you get more knowledge, you get less risk. Then you can try iteratively to fine-tune the estimate and say maybe 2nd weeks of August, and then at the end you can really have a date. If you have no idea on how to compute this range here at the beginning, you can have this cone of uncertainty rule, which say more or less multiply by 60 and 160%. So if you plan an 8 months delivery, you can say at the beginning, I have no idea about the project. It will be sometime within May and December, but let's sync in a couple of weeks after we started, and then we can fine-tune it more and more. Okay. Or if you are in a company where you really need a date, and that's something you cannot change, then you can move the uncertainty to a feature buffer. No? So if you think that in 8 months, it's likely that you are able to develop and release 10 features, you should at the beginning define at least a 30% of them, a 30% of the features, which is a buffer, and you say, consider that we commit to do all of them, but at least we keep a 30% of them as something that we can it's not a must-have, and then we can leave them out. Okay? Yeah, this is also another rule that say that early in the you can have a feature buffer or a schedule buffer, but Steve McConnell say that you cannot have both. I mean, you need to keep one of them, no? At the beginning of a project, you have a firm schedule or a firm feature set. You cannot have a sharp deadline and sharp set of features. Yeah, then about team workload. Also, another risk when you make a plan from scratch is say, okay, we have this list of tasks. Everyone is this number of story points or this number of days. Then we have this number of developers, we divide, blah, 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 and we try to fill the developers with all the tasks as much as possible. So actually, if you do this, then it's like filling a highway with cars. No, there is some traffic going on. And it has been demonstrated that filling too much a developer with too many tasks in parallel can really affect productivity. And then there is this famous chart from the 90s that says that after you give a developer a third task, productivity goes so low that the developer is doing even less than when he's doing just one of them. So do not overload your team. 4 tips. Keep estimates simple. This is a chart from a book called Agile Estimating and Planning. And the author, Mike Cohn, say that there is a diminishing returns in the accuracy of defining a project, that if you put too much effort, yes, at the beginning your accuracy is increasing, but at some point you are kind of overfitting, and then it really doesn't matter to spend too much time at the beginning to really have an accurate estimate. Just try to start simple, have something reasonable, and then focus on iterating and fine-tuning afterwards your estimate. And that's why there are tips like Fibonacci units to make estimate, can be days, hours, story points, or whatever, but these make you natural, reduce the temptation to overcomplicate, because you have to choose between, for example, 13 days or 21 days. You are not discussing if it's more 15, 16, or 17, no? Yeah, and another tip is about story points. So why do people use story points when they make plans? The main reason is that by using story points, you really make clear the difference between the size and the complexity of a feature with respect to the duration. Because when you try to estimate via story points, you are saying every feature, how complex and how large it is, and they are just on a relative scale. You are not trying to say how long it will take, because making the two estimates is quite complex. Because when you try to say the duration, how long it takes, there are many things that affect the time it takes. Because, for example, in a team you can have time dedicated to maintenance, people are being sick, there are meetings, there are training, emails, whatever. And at the beginning of the project, if you try to estimate the size and how long it takes, because you understand how much the team can close every sprint, is quite complex. So having a relative scale which is completely separate than elapsed time is a good way to start. But then once you have this estimate, how do you take and derivate a duration estimate? Usually you run a few sprints or a few iterations. At the end of every iteration, you look at how many features you have closed, how many story points were for each feature, and then you guess what's the velocity of the team. So for example, here the team has closed 24, 28, 22, 26 story points. Then you say, okay, more or less our teams closes 25 story points. That's the velocity. And this already takes into account all of this stuff here, no? Because this is measured statistics. So the duration is more or less the sum of the remaining story points and velocity. So that's why it's better to have estimates a little bit after the project starts. Sixth tip is anticipating risk. You want to have also, for every feature, a bit of thinking and consideration on what's the risk of a feature. No? Maybe there are a risk with some framework that you know less, or there is some legacy system which you want to integrate. So at the beginning, you have really no idea if this estimate is correct. You know, there is larger uncertainty. So usually the tip is to start from here at the beginning. Or another thing, again, from Daniel Kahneman, which is more on the psychological way, is to do a pre-mortem. Because usually when a project fails, at the end you do a post-mortem or a retrospective. You say, why did we fail? But what you can also do is a pre-mortem. So before starting the project, you say to the team, imagine that we are a year into the future, we implemented the plan and it failed. So now write down what happened. And this is a way to exercise your brain to think of what can go wrong in a project. Another way to anticipate risk is the way you design user story and features. In this book, Pragmatic Programmer, it's recommended to design features like tracer bullets. These are tracer bullets, it's the kind of guns that you can see the trace where it goes. And this means that you don't want usually to have features that reflect the layer of your architecture. So sometimes we tend to say, okay, let's first build a database, then we'll do the backend, and then we have another story about the front end. But usually, even if you make some technical debt or some shortcut or some dirty code, it's often better to have a small minimum development on the full stack, because this lets you anticipate the risk of finding things that can go wrong during the integration of all this stack. Okay. That's it for what we had planned. I hope you had some good thoughts. These are not, of course, all ideas that come from me. There are some books that I can recommend. You have Thinking Fast, Thinking Slow. It's really a book about psychology and how we think, but it's really can be read by anyone. Agile estimating and planning is a really good resource because usually we talk about agile, but we don't think how to make a plan out of it. Can we make we sometimes think that a plan, like a year ahead plan, is just about waterfall. And this book says that this is not true. You can have a year planning with agile too. Then yeah, there are also some more old books like Mythical Man Mountain, Pragmatic Programming, but still are full of good ideas. Okay. Yeah, that's it. Here you find my contacts if you want to get in contact with me on LinkedIn, on Twitter. I run a podcast in Italian called Intervista Pythonista, which I recommend you listening to. This is a small advertisement. If you have questions, either write them on Slido or use your hardware. Thanks.
Thank you so much, Marco. Does anybody have a question? I checked through this Slido and there's no question on Slido. So if you have a question, feel free to raise your hand and we'll be taking them now. All right, thank you.
It's not really a question, but I just want to say how your talk reminded me of a project that we did a long time ago, and it was about migrating literally thousands of websites from one hosting service to another. And the way that the manager estimated the time and effort is he essentially asked, how much data do you have? And they said like 18 gigs. Okay, what's your upload speed? It's 100 megs per second. And he took the calculator and he said, okay, we can do it in 7 days. Why? Of course, it took us 7 months, not 7 days. But thank you.
Do you want to say something to that? All right, so I have a question here. How to deal with external interruptions? How do we deal with external interruptions?
With interruptions? External interruption, okay. I mean, that really depends on the team, no? I mean, external interruptions somehow are things that are part of this, no? Are things that slow the team from the development of the project, so you can have whatever system you prefer. Where we work in my team, that is also here, I say hi, we use a technique called buffer illegitimus non interruptus, I think is the correct name, that at the beginning of every sprint, we reserve a capacity of the team dedicated to interruptions. So let's say every sprint we give 5 story points dedicated to interruptions. At the end of the sprint, we look if that was actually true and they occurred. And that's a way for us to measure how many interruptions we have, how frequent they are, and so, and also to plan them ahead, no? Because if we know that every, I mean, it's true that they are external, but somehow they occur. So just plan time for them. So that's what we do.
We have another question here. Okay, so how to communicate to business or management the time intervals of load if they require it?
How do we communicate what?
How to communicate to business or management the time interval and the subload if they require it?
So the question is, how do we communicate to business or management this large range of possible outcomes? That's a very tough question. I mean, it's a matter of transparency, no? So if the company has a culture that really makes this feasible, I think it's better to try to be transparent. And then if they give a pushback, then we try maybe to put ourselves in their point of view and to ask, why do they want a sharper range, no? So maybe if we try to understand why is a sharper range needed, then maybe we try to collaborate and find some ideas. I mean, I think it's better to try to understand why do they need this sharper range.
All right, any other question? No other question. All right.
Lunch is calling. Okay. Lunch! No.